Welcome back, Chemistry 30. This is Unit 2, Booklet 15.2, Solution Concentrations. And if you had a textbook, it's pages 462 and 464 to 468. The objectives here, to look at dilute solutions, concentrated solutions, and molarity. State the concentration of solutions in terms of molarity. So that'll be the first half of the video, and the second half will be looking at preparing standard molar solutions and looking at how to dilute solutions. Okay, so first of all, dilute versus concentrated solutions. So if we're looking at just a qualitative aspect comparison, dilute would be a small amount of solute in a given amount of solvent, whereas concentrated would have a larger amount of solute in that same given amount of solvent. So basically comparing one to the other, large amount versus small amount in terms of what's being dissolved in it. Concentration, therefore, is looking at how much solute is dissolved in solvent or solution. If you recall earlier, solution contains the solute and the solvent. So that's what we're looking at here. And if we're looking at the next part, molarity, we're looking at solute per solution. In other words, solvent and solute together. Now the little formula I like to use here is C equals N over V, where N is your solute, V is your solution, and the units we look at here are moles of solute over liters of solution. So N is, you can think of it as number of moles, V as volume, it has to be in liters. So therefore the concentration will be moles over liters, or quite frequently that is shortened down to just big M, which is read as molar. Molar concentration, or moles per liter concentration. I also included something else here written in black. Quite often moles of solute will have to be converted to mass if we're actually measuring it to make solutions, as you'll see in part 2. Or in the question, as you'll see shortly, sometimes we're given a certain amount of grams of solute. We have to convert it into moles before we can do this calculation. Okay, there's a few examples I pulled from the textbook here. What is the molarity of the following solutions? So if I look here, if I have 2.5 moles of potassium chloride and enough solvent to make a 1 liter solution, what's the molar concentration? So ideally, like every other problem, you should write down what information you're given and write down a question mark by what you're asked to find out. All of these are asking you to find molarity or molar concentration of these solutions. So C is my big question mark. I'm given moles of solute, liters of solution, etc. So this one's easy enough. 2.5 moles divided by 1 liter, I get 2.5 moles per liter, or 2.5 molar if I want to use the alternate unit here. Moles per liter or molar. Okay? Next one, what's the molar concentration if I have 0.875 moles of ammonia and enough solvent to make 150 milliliters of solution? The thing that should ring a bell right now is that this is in milliliters, it needs to be in liters. So we have to convert that into liters first of all. And of course, from everyday use, you know that 1,000 milliliters is a liter. If you have a 750 milliliter bottle of pop, you know that's 0.75 liters. So working that out there, my moles of solute is fine, 0.875, but here I got to divide by 1,000. Milliliters cancel, I'm left with liters, 0.155 liters. And then it becomes like the previous question, just simply C equals N over V, 0.875 moles over 0.155 liters, 5.65 moles per liter, or 5.65 molar. Okay. Next, what's the molarity of each of these? This time it's 0.96 grams of magnesium chloride in 500 mils of solution. So yes, we have to change that to liters. And oh yes, we have this in mass. It's in grams. That solute needs to be converted into moles. Now, if you recall from our Unit 1 review, to go from grams to moles using your Y chart or unit conversions, we need to find the molar mass of magnesium chloride. So we have 1 magnesium, 2 chlorides, 24.3 plus 2 multiplied by 35.5, 95.3 grams per mole. So that's going to be the first little conversion there, 0.96 Gs multiplied by 1 mole over 95.3 Gs. The Gs cancel, I'm left with moles. Don't bother rounding off just yet, because we're going to save that for the end. And then, of course, 500 mils, decimal 3 places to the left, 0.5 liters. So that lends itself to 0.011073, that long number, over 0.5, 0.020 molar. 4 sig figs, 2 sig figs, so my answer has 2 sig figs. Okay. The next question, what's the molarity of 9.33 grams of sodium sulfide in, I'm not sure why I wrote in twice there, 450 mils of solution. So maybe I'll get you to pause the video now and try this for yourself. It's very similar to this one, finding the molar mass, then going from there. Okay, if you had a chance to work through that question, first of all, 2 sodiums and 1 sulfide, that gives you 78.1 grams per mole. And working that out, converting 9.33 grams to moles, we get this, 0.119462227 moles. 450 mils, of course, is 0.4500 liters. So working that out, we get 0.265 molar. 4 sig figs, 3 sig figs, so I need to have 3 sig figs in my answer. Okay. Looking at something different here. How many moles of solute are contained in the following? So 15.25 mils, and it's a 2.1 molar solution. How many moles? So here I'm asked to find something different. N is the unknown. Big C, I have volume. Move the decimal 3 places to the left. 0.01525. So there's a couple of different ways you can look at this. C equals N over V. If we're looking for N, multiply undoes division here. So multiply by V, N is equal to V times C. Or quite often what I show in grade 10 science is this triangle of terror or pyramid power, whatever you want to call it. C equals N over V. If you arrange the original equation in there, you can solve for any of the variables. If I'm looking for V, you can see it's N divided by C. If N is what I'm looking for, what's left over, C and V, they're side by side, that implies multiply. So whatever way you slice it there we have. Now notice here my 2.10 molar, I represented the unit as moles per liter so that you can see how it cancels out here, how the liter part cancels out. So I end up with 0.0320 moles. Now, as I mentioned before, quite often we need to figure out how many grams of solute there is. So I just added a further part to this question. If you needed to convert it to grams at this point, of course we need to find the molar mass of calcium chloride, CaCl2. So that's what I do here. 1 calcium plus 2 chlorides gives me 111.1 grams per mole. So then if I needed to convert moles into grams, because as we'll see in the next part, we're going to be making solutions here of known concentration. We'd have to figure out how many grams that is. So 3.56 grams of calcium chloride, if we needed to do that. Okay, the last question before we take a break here is very similar. How many moles would be involved if I had 125 mils of a 0.0500 molar magnesium hydroxide solution? So I'll get you to pause the video and just simply find out how many moles that works out to be. Don't bother converting into grams. We'll just go as far as moles. Okay, if you had a chance to look at that, looking for N, we know C, we know V. 125 mils is 0.125 liters. Then substituting that back into the formula here, you should get decimal 0.00625 moles. So that's the first part of this video. We should be able to do this quiz now, and then we'll look at part 2 in a bit. See you shortly.